Stop recording. Okay, somebody press the record, no? So please stay. This is recording now, eh? Stop recording is the command. So yeah, somebody press record. Okay, I suppose to. Okay, look. You see this picture, no? Conic section. Okay, this is a special curve. By the way, quadratic curve, in which is formed by the intersection of the double cone and one plane. And the only difference is the angle of this plane intersecting the double cone, no? So we have the family, no, of the conic section. The first one is ellipse. Ellipse. Ellipse is a closed figure. Okay, I want to discuss it in detail, everything inside this figure. But you see, we have two axes. This is the major and this is the minor. But circle, no, circle is a particular example. Circle you can consider like an ellipse. But in this case, circle is completely rounded. So the distance in this direction and this direction is the same. This is a circle. You know very well in college algebra. This is ellipse. And well, the problem is when the angle in which the plane cut off the double cone, see the angle is 0. It's a circle, so the angle is less than who? Less than the angle of the cone. So any cone have a specific angle, no? This angle, let me call alpha. So now we have another angle, que is, I don't know, theta. Que es the angle in which the plane cut off the double cone. And when it's small, we generate ellipse. However, we have two more conic sections, important. Parabola. The parabola is very well known because in college algebra we have one topic specific for the quadratic function, but now I want to discuss it in detail. Parabola. And the parabola is only one branch. Of course, it's closed curve, no open, no close. This is closed because it's completely, for example, so you pick one point, you can moving around and you come back to the same point. It's open. Open, no, close. This is open because open is we have no, this space is impossible bounded. This is a parabola, and hyperbola is also similar as open, but you contain two branch. This is hyperbola, and this is parabola. We discussing in detail today everything about this concept. Let me try to start watching details. Okay, this, by the way, I sent to you attachment and this link, one PowerPoint. Okay, cover this slide and some more slider. Just when you have time, you watching this. Okay, in this second slide, I present again the conic section, the four conic section, the name, circle, ellipse, hyperbola. The name, circle, ellipse, hyperbola, and parabola. It doesn't matter the order. We study first ellipse, secondly hyperbola. Parabola second, because it's, in my opinion, it's better to understand. And hyperbola is the last one. And you consider que circle is a particular case of the ellipse. Below, it's a one particular, when there's something happen. Okay, so one more time, I show you the picture. Ellipse, the problem is, Professor, ellipse look like that, or like that, or like that. The problem is that we have two kinds of ellipse. Let me call horizontal and vertical ellipse. Likewise happen with the parabola and hyperbola. We have, for example, in the parabola, this parabola that you see now here is horizontal because open, in this case, to the right. Maybe open to the left, another parabola, or open over or downward. So we have basically, I can characterize the parabola like we have, you know, let me try to explain again. When you have parabola like that, or like that, a horizontal, H parabola, horizontal. However, you have parabola like that, or like that, only one branch, not two, a vertical. So open, left, open, right here, right, to the right direction, to the left direction, open over, and open downward. Open downward or down. Let me fix it, my spelling. Downward. Okay, so now in that direction is vertical, up, down. In that direction horizontal, right, left. We have four kinds of parabola that we need to identification. You can see immediately the examples to illustrate how you can identification. Not always in the example is given in the nice standard form. No, and you need to manipulate in order to express a standard. And the hyperbola, okay, we have two branch. We have this kind of the hyperbola you see here, but this is not the unique. This is vertical. This is vertical hyperbola. You can open like that. However, we have another kind of hyperbola can open like that. Okay, I try to draw like that. Look, it's a horizontal. It's a horizontal, and it's a vertical. Entonces now we associate immediately with the equation. No, now because this equation is super particular, and we associate with the most important points that you need to define to characterize efficiency, the conisection, and different distance, important, and different lines split or reflect the conisection and different asymptote, because sometimes have asymptote very similar to the rational function. Okay, let's focus on the leaks. Now, guys, I know that you need to memorize too many names, but this name is important. Okay, we have two kinds of the ellipse. This ellipse is horizontal ellipse. Why? Because we have two axes. The major axis is the graded, no? Is this axis. This is the major axis. Is, you know, is parallel or coincident with the x-axis. When the major axis is parallel or coincident with the x-axis, entonces es horizontal. Otherwise, when the major axis, in this case, is this axis, is parallel or coincident with the y-axis, entonces es vertical. Entonces, how you identification? Look in the equation que es ellipse. Well, look at this equation. Let me try. This equation say x minus h squared divided by a squared plus y minus k squared equal b squared, and also is equal 1. Of course, this equation right here is the super elegant equation. Okay, the name of this elegant is standard. Okay, standard. The first example we are doing is standard. M, if I forgot the M, standard 4. The first example we're doing and are nice. Always I give you the problem in standard. Oh, so identification, who is H, who is K, who is A, who is B. And important, que the right hand side of the equation is 1. Si es no 1, I need to do something in order to express it using 1. And who is H and K? H and K is center. So any ellipse has one center at the point H, K. This is the terminology he uses. This letter H and K. H, of course, is the X component. K is the Y component. And this is the point center. That one. Bang. Bang. Que no necessarily is the origin. Well, the origin is H and K. Both are 0. Pero si no es 0, well, it's one specific point. Okay. One more important characteristic have ellipse. Ellipse have the major axis, que is this axis. Let me use in green color. This axis is the major axis. We have the semi-major axis, que is a half of this. Semi-major is a half. Is this distance? Oh, this distance because it's the same. In this case, as her name says, is horizontal ellipse. Therefore, the major and semi-major are segments parallel to the x-axis. And the vertical, this is the major axis. And this is the semi-major axis. And the semi-major is this distance. And this distance, semi-major axis, is important to understand because it's A. A represent, look at the formula, we have A squared. This A is distance. And this distance is the semi-major axis. And who's B? Well, C is a semi-minor axis. Let me use another color. That distance is B. That distance is B. Important to say something. Always, A is bigger than B. This is the most important thing you have to remember in the list. Okay, you have two semi-major axes, semi-axis, minor or major, but it's obvious that major is bigger than minor. The word indicates this inequality. But we have another important, que es C. C is the focal distance. Our ellipse, guys, have two focus. Two. Focus is important point I need to plot to understand the graph of the ellipse. We have two. And this distance between the center and each focus, in plural, say foci, is C. And the relationship between A, B, and C is this formula that personally I like to write differently. I memorize, for example, A is the bigger of distance. Therefore, the bigger is A squared is equal B squared plus C squared. Okay, by the way, it's the same of this. But in this case, I don't know why, in the picture, I isolate the C. Because it's the formula for C. Because A and B is easy to understand because you look at the equation, look at that. You look at the equation, this is a squared, and you apply square root, you get a, and you apply square root here, is b. A and b is I have a and b in my hand. So using the formula is c squared is equal a squared minus b squared. Oh, much better. C alone is square root a squared minus b squared. Okay, C, repetition again, is the focal distance. The distance between the center and the focus. How you recognize que es vertical or horizontal? Easy. Because, look at that. In this gets vertical. You see, you suppose always que this inequality is true 100%. So A is bigger than B. And you see the association between A and Y. Therefore, that indicates us que the major axis is coincident or parallel to the Y axis. In this case, the bigger, que es A, is coincident, corresponding in the same position in the equation of the x-axis, of the x variable. Okay, entonces now the conclusion is this is horizontal helix. I promise. Okay, you see, we practice. We are doing 3,000 problems. Okay, we practice this. In the review packet, we are doing another bunch of problems, but you need to be familiar from now to the terminology of the elixir. Okay, this is the quick tour. Now today is a quick tour to understand a little bit the conic section. Quick tour. Of course, today we have time, to do at least, not totally, I suppose, pero almost. Okay, now suppose the parabola. Now, parabola is another constant. Ya no A and B anymore. No. Parabola, I say que es open. So parabola open, in this case open over. But in this case, look at the equation. The equation, no. The most important point in the parabola is, let me try to make zoom to see more clear. Look, we have vertex. We have no center. Parabola have no center. No. Because to have center, we need a closed figure. It's a center. Parabola have no center. Parabola have vertex. Parabola have focus, but only one, not two. Remember, the elixir have two focus. By the way, I forgot to explain that elixir have vertex also, but two vertex. These are vertex 1, vertex 2, no? And this is co-vertex. And some book calling differently, calling endpoint of the minor axis, because it's endpoint of the minor axis. Okay, those are two vertex in the elixir. However, in the parabola, no. In the parabola, only one is this. Sorry. We have one focus, no two. And we have two important lines, que is the axis of symmetry. Look at that, axis of symmetry is one line, que normally we are doing dotted line, and this dotted line split the parabola in two equal parts. That is the reason que es axis of symmetry. O sea, that distance is exactly the same that distance. So this is useful because sometimes you don't have complete information about this. So you obtain 1 point here and one specific x and one specific x. I know very well okay, in the other minus x is the same y value, no? The same y value. But no, this is because it's a vertical parabola, no? In the horizontal is different. Okay, one more important lines. Axial symmetry, we saw that. Directrix, another important line. Directrix is a line totally outside the parabola. Because the most important is that distance is the same distance of the distance between the vertex and the focus. So this distance, by the way, is P in the formula. And this is also P, but outside. So you are doing the vertex. And suppose that I determine, you look in the equation, that the parabola open over, okay. Entonces, P distance is a focus, is a vertex, is a focus, and P distance down in opposite direction is directrix. Directrix is a PP, directrix line. It's a line. And what is important? Well, it's important in the proof of the formula for the parabola. I want to omit the proof, but it's important to say something. No, you pick one point on the parabola, and this distance is the same. It's equidistance. Now the parabola you can define like a geometric place, such that the distance from the focus to any arbitrary point on the parabola, and the distance, I make a mistake here. This distance is perpendicular, of course. This distance is perpendicular, so this is 90 degrees. Look at that, 90 degrees. But that distance and this distance is the same, so you form the parabola. Entonces, what is the important point in the parabola? Vertex. Focus. I forgot something. I forgot. Look at that. I forgot this orange segment. This orange segment. I put it lacto rectum. Lacto rectum is, you know, the name in Latin. But in English, normally this is called focal diameter. Focal diameter. And this is very interesting because give me information how wider or how narrow is our parabola. Suppose that our parabola look like that, or like that. Oh, entonces the focal diameter is this segment. The focal diameter here is this segment. Entonces now it's obvious que it give me information how wider or how narrow is our parabola. P. What is the, how you find that? Bueno, passing through the focus, sorry, and this distance is 2P. And this distance is also 2P. Okay, let me summarize the segment. This segment is P. This segment again is P. In total, together is 2P. And you get that point, by the way, that point is called endpoints of what? Of focal diameter. So now to get a decent graph of the parabola, we need define clear, vertex, clear, focus, clear, endpoint focal diameter, here and here, 2 points, clear. One more you need to define. You need to define axial symmetry and directrix. Yeah, when this information is enough to do the graph of decent parabola. Bueno, but what's the problem? How do you identify a vertical or horizontal parabola, professor? Well. Look at the formula. Let me make a zoom. This slider. This slider. Look. Okay, cool. This and this is horizontal. Number 1 and number 2, horizontal. And the formula is the same. Look at that. It's that formula. It's the same formula. But what is the difference? The difference is that the value of P, when it's positive, the parabola open to the right. And when it's negative, the parabola open to the left. How you recognize, how you differentiate vertical and horizontal? Ooh, okay. Let me try to make easy to understand this, because if you include H and K, it's more complicated. H and K is the coordinate H, K, H, K. Obviously, is the coordinate of the vertex. So the vertex is H, K. In any parabola, always. It doesn't matter, okay, open it to the left, to the right, or up or down. However, in the formula, when you see the formula, you can differentiate. Suppose que H and K, to understand more clear, is 0. In other words, the vertex of the parabola is located in the origin, 0,0. Suppose. The equation is of the horizontal is y squared equal 4p x. Wow. I suppose to simplify the thing, que H and K is 0. Si es no 0, bueno, you include the formula, no? But si you see que y is square and x no square is a parabola. What kind of parabola? Horizontal. Horizontal. Likewise, or no, otherwise, differently, if the equation is differently, is, look, is x squared equal 4py. You see it's different. The only thing is the permutation, x and y, and when you permutation x and y, our parabola rotate 90 degrees. Entonces this is vertical. This is vertical because vertical parabola, because the quadratic part, so square, power 2, is located in the x, not in the y. The equation completed include the translation. A piece of k is y minus k squared equal 4p x minus h. In this case, the same equation, the only consideration is that the vertex now is located at the point h, k. Cool. Like y here is x minus h squared equal 4p y minus k. Keep in mind, guys, consider always that h is associated with the x and k is associated with the y. Always. Not only in the parabola, always. In any conception. Okay, this is conclusion. How many points I need to define to understand the parabola? Well, you need, first of all, the vertex. This is the most important one, h, k. After that, we need focus, que this distance is p, que p you can see in the formula, no? Let's see an example more clear, no? And the endpoint focal diameter is 2p, 2p, 2p up, 2p down. Directrix, same distance p, is this line, que by the way is vertical line when the parabola is horizontal. And the axial symmetry is horizontal line when the parabola is horizontal. And the parabola vertical is totally differently. Okay, is when the parabola is vertical, the axial symmetry is vertical line, and the directrix is horizontal. Not necessarily memorize, it's an intuitive idea. You know very well, or a little bit, how look like the parabola, and so we have two axes, two lines, the axial symmetry, que split the parabola into equal part, and the directrix is out the parabola, same distance of the focus. Okay? Okay, quick tool. Now let's move on to the hyperbola. And now, after that, we are ready to do examples. Okay. Hyperbola contains two branches. Hyperbola contains two branches. Entonces now we have two kinds of the hyperbola. Of course, the horizontal hyperbola and vertical. How do you know this name? Because in the hyperbola we have two axes. Two axes. The most important is the transversal axis. Transversal axis. What is that? It's the most important. The other is not important. Is how you recognize that the transversal axis is parallel or coincident with the x-axis. In this case, no, it's parallel or coincident with the y-axis. That is the reason it's vertical. Look at the equation. In the equation, and to say now the students keep in your mind the idea for the A and B and the ellipse. And the ellipse A is the bigger, B is the smaller. No, in the hyperbola, not necessarily is in that order. No. Erase in your mind is. Now, A is the coefficient associated with the X. Well, no. A is associated with the positive. So hyperbola have positive and negative. It's the only conic section that have negative. Only negative. So now, when you see that A is associated with the positive part, that by the way is the X part, entonces es horizontal hyperbola. So repetition. A associated with the positive, greater than 0. And A is associated with the X. Therefore, our transversal axis o es coincident with the X o es parallel to the X. That is the reason que es horizontal. You see in the other equation? No. In the other equation, A, que is always the positive part, is associated with the Y. Therefore, that means that our transversal axis is coincident with the Y or parallel to the Y. So you look at the equation gives me that information. The positive part is A, associated with the X or associated with the Y. But again, we come back again to the horizontal. We have center. The center is always H, K. Center, repetition center. The only conic section that have no center is the parabola, but ellipse yes, and the hyperbola, of course. We have also focus, in plural, foci, in plural, que es the distance C. In this case, by the way, well, let me explain first of all. Forget about foci, no. Vertex. In plural, vertex. This is the plural of vertex, no? Vertex. But in this case, you have two. That is a plural. It's this point and this point. And this distance is A. Okay, and this distance is also A. In opposite direction, no? In the scenario of the vertical, we have this vertex and this vertex. It's the same idea, but parallel or coincident with the Y. This distance is A, this distance is A. Que no necesarily A is bigger than B, no. It's A and B. A associated with the positive part, B associated with the negative. What about B? Well, B is confusing because B, you don't see clear. Because B is, to visualize a little bit, how would I be? You are doing this famous reference rectangle. So this construction is called reference rectangle. This is it. This distance is to A. We have A here, and this distance is to B. So this distance is B, and this distance is B. And by the way, the connection here is the center. We are doing this auxiliary construction that do not belong to the hyperbola, but help me to understand a little bit. So you are doing the reference rectangle here. You connected the corner of the reference rectangle. Okay, by the way, that line passing to the center, and this is the asymptote. The famous asymptote that we studied before in rational function. In conic section, you see again, no, asymptote is not only for the rationals. A lot of functions contain asymptote. In this case, we have two asymptotes, plural. And this asymptote means that the curve, in this case, the blue color, approach but never touch this. And the formula, by the way, is a slang asymptote, no? A slang asymptote. The formula to determine the asymptote equation, is a line, is y equal plus or minus b over a x, because b over a represents the slope. Look at that. This is a, this is b, and b is similar to understand rise over run, and this is x. And in this case, the supposition is that the center is located in the 0,0. Suppose que the center is not located in 0,0. Okay, no problema. Entonces now my equation I can generalize like that. Y minus k is equal plus or minus b over a parenthesis x minus x. Okay, this is the formula for the asymptote. Entonces now, okay, I forgot something always. Well, in this case, similar. The only is that the formula change a little bit. Is plus or minus a over b, x. But you have another point, is the center. So says y minus k is the same. Plus or minus a over b, parenthesis x minus. Okay, cool. One thing I forgot. I forgot the distant focal. Well. I see. Okay, that distance is a. From the center to the vertex is a. This distance is b. From the center to any point here, b is a b. But c is from the center to one distance is the focus. The focus is this distance, the focal distance in this case is bigger. It's just bigger. The relationship between this quantity ABC is c squared is equal a squared plus b squared. Don't confuse it with the elixir. The elixir is different. The elixir is a squared is equal b squared plus c squared. This is for the ellipse. Hyperbola, no. Hyperbola, who is the bigger? In between ABC, C is the bigger. Hyperbola. Entonces now, conclusion, hyperbola. We have center, okay. We have vertex 2. We have focus 2. We have endpoint of the this is called a covertex. Endpoint of the minor. Actually, it's not minor, it's covertex. Vertex and covertex. And we have the famous asymptote. Okay, 2. So this construction is mandatory to do a decent graph of the any condensation. You are doing like that. Hyperbola, what is the hyperbola look like that? This is nothing for me. I need detail. Just in case, I share with you that when the class is over, I want to send one Desmos script que I create to study in detail the condensation. You see, and I want to share the screen now and the problem, and you want to see in detail. Of course, the solution in the test number 4 we are doing using this script, and this is very, very useful to understand this. Okay, so now I suppose you have 3,000 questions because total is new. However, let's see one by one in the example. Of course, The idea is anticipate the name, anticipate the segment, anticipate the point, okay, you need to be ready to hear this idea. Okay, let's move on to example one. Example one, example one, example one, example one. In example one, I have x squared over 16 plus y squared over 9 equal 1. Wow, easy example. Of course, it's the example one. It always is easy. And so you identification clear. Wow, it's ellipse. How do you identify that? Okay, in general, when you see one equation can contain x squared and y squared, and it's plus in between them, o es elixir or it's a circle. So what is the different elixir circle? One, when the number is different, 16 and 9, it's obvious que es elixir. Si el number is the same, 16, 16, or 9, 9, entonces es a circle. Okay. However, when you see one conic section, the equation is x squared and y no square, or y squared and x no square, es obvio que es parábola. And the detail of the parabola is horizontal, vertical, after we discuss. But this is my problem now. Ellipse look like that equation. And hyperbola in general is x squared minus y squared. Okay, is hyperbola, or professor y squared minus x squared. Depending on the orientation of the hyperbola. Si es horizontal or vertical hyperbola. Okay, but it's not important now. The important for me is identification. This. Are you clear how you identification get our equation is given in the example one look like ellipse? Okay, and you compare mentally with this equation, que is x squared over a squared plus y squared over b squared equal 1. Or I don't know si es x squared over b squared plus y squared over a squared equal 1. No idea. O is x minus h squared over a squared plus y minus k squared over b squared equal 1. O y minus k squared over a squared plus x minus h squared over b squared equal 1. Es obvio que no, because we have no translation. So that means that the center of this ellipse is located at the point 0, 0, because h and k both are 0. So what is the orientation? How look like my ellipse? Look like that, or look like that? Well, the professor explained at the beginning que I suppose que A is always bigger than B. So you take in the ellipse, of course. What is the bigger number between 16 and 9? Oh, 16 is the bigger. Because I consider que A squared is 16 and B squared is 9. Therefore, automatically A4 square root 16 is 4 and B is 3. Okay. Entonces now my equation look like that, no? So A is the bigger is associated with the X. Therefore, when I finish that problem, my elixir look like that, horizontal. And of course, the center here is 0, 0. So this is the x-axis, y-axis. It's a rough sketch. After we see clear in the script that I create for you, for my student. Okay, entonces now A es 4, that distance is 4. Therefore, that point is a point 4,0. In the other direction is 4 also. That point is a point negative 4,0. Now, here, B is 3. That distance is 3. At that point is a point 0,3. And this point is the point 0, minus 3. Okay, we almost finished. I need only C. C. The formula is A squared is the bigger is equal to B squared plus C squared. If I want to find C is equal, I put A squared minus B squared and apply square root both sides. Actually, C squared, I need to see because C is the segment of C squared. So it's square root 16 minus 9. Okay, 16 minus 9 is 7. It's a square root 7. And the square root 7, I put it, well, actually it's a rational solution, but you can find the decimal approximation like a 2.646, 3 decimal place always. Now my focus is located here, one distance. Let me try to use in green color. Is that distance, and this point is a focus 1. It's located at the point 2.646,0, and the same distance in the opposite direction is minus 2.646,0. And that's it. Yeah, I did the graph of my ellipse. And that's it. By curiosity. This is curiosity. It's not extremely important. It's just curiosity. We have one element or one parameter that is called eccentricity. Eccentricity is denoted like a letter E. Eccentricity. Eccentricity is the ratio between C over A. Well, in this case, eccentricity is C is radical 7, A is 4, remember. You want to see a decimal approximation is 0.66. What is eccentricity? Eccentricity give me a measurement of how rounded or flat is our ellipse. For example, in this ellipse, the eccentricity is 0.999, almost 1. Because eccentricity equal to 1 is just a segment line. However, in the same idea, the eccentricity change, okay, is 0.5, eccentricity 0.5, 0.4, differently between major axis and minor axis is short. And a specific circle eccentricity is 0. 0 means totally rounded circle, ellipse with the eccentricity 0. At the beginning, the astronomy in the 2 years ago, 2 centuries ago, believed that the solar system, suppose the sun, and this is the planet, for example, the Earth, maybe whatever, Jupiter, rotate like a circle, and this is not true. Not true, and the NASA discovered the eccentricity for each planet. But by the way, the astronomers believe that circles orbit because the eccentricity is too small, but it's 0.05. Okay, entonces now, however, another astronomer after discovered differently idea, the orbit of any planet is actually ellipse, depending on the planet, and each planet have different eccentricity. Okay, and by the way, the sum is planet. The sum is located in one focus. We have two focus in this elixir. The sum is located in one focus, and the planet travel in that direction always. Well, not always. There are planets that travel in hour, but the majority of planets travel in this direction is counterclockwise. I guess so, counterclockwise. Let's to make sure. This is curiosity, guys. Don't forget about the planet. Maybe you are astronomer one day. You know, for a moment, the most important for me is that you understand the elixir. Let me try to simulate in Desmos this example. Okay, let's do it. I want to open Desmos. I want to share the screen for the Desmos, and you let me know see you see or no. You see? You see? You see? Okay, we see. Now, I'm moving to example one. Okay, the example I want to discuss with you. Not necessarily today. We finish the next lecture. Suppose example one. Example one is this. Look, x squared over 16 plus y squared over 9 equal 1. I do the graph. Bam! Look at that. It's elixir. Oh, nice. I like so much. But if you know in the piece of paper, que A is 4. You set out here. Well, the center. Well, A is 4. I'm moving here 4 to 4. B is 3. You can, if you want to know, move the handle. You can type it directly on the number. Okay, 3. Okay. And it's so big. H and K both are 0. Look at the 0, 0, 0, just 0. Just 0 and 0. Because the center I discovered in the equation is located at the origin. And P no, because P is for the parabola. O sea, en the elixir es H and K, A and B. Entonces, you identification. Bueno, professor. I understand que es the horizontal elixir, right? And you click here and you see, bam! The everything that you need. You need the center, 0, 0. You need the vertex, 4, 0, negative 4, 0. And the major axis, and the minor axis, the co-vertex, whatever you want to call it, is 0, 3, because B is 3, so the segment that I put in red color is the B, and 0, minus 3, and the focus, remember, que we obtain approximately, que es radical 7, que es 2.6646. Focus 1, focus 2. I call it like that, but some people can't call it. Focus 1, focus 2. Doesn't matter the name. The name is not important. The important is the coordinate. Any question, guys? You understand very well? Yes or no? All right, show me. No question, Giselle. And the rest is okay? Okay, you said lesson. Good. All good, dice Jose Cabrera. Let me try now to come back to the whiteboard. Example 2. A little bit complicated. I complicate little by little. Example 2. Say, do you see whiteboard? Please help me to guide me. Do you see whiteboard or no?
No.
No. Okay, cool. Because somebody I forgot. Switching to whiteboard. Switching and open that. Now?
Yes.
Cool. Suppose this example. Okay, at the beginning it look like tricky, but no, it's easy. 25x squared plus 9y squared equal 225. You say, wow, what the hell is that? It's elixir, of course. It's elixir because when you see x squared plus y squared, and you have two numbers in the top or in the bottom, it doesn't matter. Pero in the problem is que this ellipse is not expressed in standard, because to be expressed in the standard, my right hand side would be equal 1. This is the standard. You need to guarantee in only analysis, in all the analysis you should do. So it's easy because the only thing you need to do is divide the entire equation by 225, 225, 225. Okay, so now you divide 225 divided by 25, or basically you put 225 divided by 25 in opposite direction is 9. So far it's x squared over 9 plus 225 divided by 16 is 25. This is y squared over 25 is equal to 125 divided by 0. So the one ready. This is now in standard. Everyone follow me?
Yeah, we follow.
Now, one more time helping. Okay, our center of the ellipse is located at the point 0, 0. How do you know? Because I don't see any transformation like that vertical shift or horizontal shift. When you take x plus or minus h, this is the horizontal shift transformation, and when you have y minus k or plus, doesn't matter, to the left, to the right, to the left, is vertical shift, but not shift. It's only 0, 0. H and k is 0. So when I want to do my graph by hand in the rectangular coordinate system, I know very well that my center is located here in the origin, 0, 0. And what about A and what about B? Who help me? A and B. Who help me?
A is 3 and B is 5.
A is 3 and B is 5. I don't think so. You forgot important concept, important idea. A is always bigger than B. So I create intentional this example, no? Okay, so now it's obvious that you, in order to get A and B, you see what is the bigger number? 25. So x squared is 25. And B squared is 9. Therefore, A is 5 and B is 3. Okay, not necessarily the coefficient can belong to the x is A. No, it's not the idea. The idea is that the A is the bigger. Si it's associated with the y, I suppose that my ellipse is vertical ellipse. And the major axis is coincident with the y-axis or parallel. By the way, the vertex is in phi, is that distance. That distance is phi. That distance is phi. Look, phi. That point would be 0,5 in the opposite direction. That is 0,-5. This is my major axis. How do you know that the major lie in the y? Because 25 is the bigger number. And the minus 3, there's a 3 here and 3 here. So this point would be 3,0, and this is minus 3,0. Our ellipse look like that. You see now in the simulation of Desmos. I finished. No, I need to find C, get the focal distance, and the focal distance. And by the way, the focals, the focus, in plural, lie on the major axis always, never on the minor. No, stay. What distance? No idea. But the formula is A squared is equal B squared plus C squared. So I want to find c squared is equal to a squared minus b squared. A squared is 25. B squared is 9. Subtraction 16. And c alone is the square root 16. Get 4. Now the focus is located. Let me use another color, maybe green. That distance here, 4. This focus 1 is at the point 0,4. And this is the focus 2 at 0,9. End the story. And this is the descent graph of the hour problem. Okay, just in case, make sure I put in decimals. And remember, in my script, I have different examples. You will remember, this script is a copy of mine. And you can delete, remove, edit new example, and you simulate. Because in the handle, you can put A and B, H and K. Okay, let me try to come back to the decimals. There you go. Do you see decimal now? This. Well, Giselle, this is the last example. Forget about this. Now I move into the second. The second is example 2, ellipse. Look. Okay, by the way, the equation is I copy without transformation. And decimal 25x squared plus 9y squared equals 220. Okay. But in the computation by hand in the piece of paper, I modify this equation and express it in standard. Okay. Let's see it's equivalent 100%. And I determine that A is 5. And B is 3. I don't touch. And H and K are 0. Okay, cool. And I discover also that this is vertical ellipse. I click here and vertical ellipse. Bam! And one more time, you see the points. Center 0, 0. Vertex 0, 5 and 0, -5. Endpoint of the minor axis 3,0 minus 3,0. Foci 0,4 and 0,9. Boom, end the story. This is easy by hand because everything is distant from the center. And you're moving 5 over, 5 downward, 3 to the right, 3 to the left, and the focus is 4 over and 4 down. I don't know, my script doing this equation, I have programming this equation inside, behind this. Any question, guys? Okay, we're doing two more complicated, very complicated. Very complicated. Very complicated. Let me erase the board. Okay, let me share the screen of the board for you. Here, over there. Whiteboard. Do you see my whiteboard?
Yes.
Example 3 now. Example 3 is x minus 3 squared over 16 plus y plus 2 squared over 25 equal 1. Wow. Okay. I have a question. This is already ellipse, yes or no? It's ellipse, yes or no? Yes, of course. This is carrera is yes. And the reason is because it's x squared plus y squared. It doesn't matter que you adding or subtracting inside the parentheses because it's just translation. Cool. It's ellipse. This ellipse is expressed already in standard form, yes or no? elixir en estándar? En estándar form. Yes or no? Opinion. Are you sleeping or you participating? Yes, Jose said yes. Because the standard is you compare with this equation, okay? You need to memorize somehow. It's not hard to memorize. This is x minus h squared over, I don't know if it's a squared or b squared. Let's see after. Y minus k squared over a squared or b squared equal. Okay, one clue to give me information that is already in standard is right hand side one. Nice, I love that. And you organize in alphabetic order x and y. Okay. One more thing I need to know. I want more. Who is the center of this ellipse? Where is located the center? This is tricky. I know, because it's h comma k, no? And who is h and who is k? Who is h in this example? Who is h? Who is h? Who is k? Huh? Come on, guy. Help me to understand this. Who is h? Who is k? Look at the equation. Sleeping? Donovan, Allison, Karim, Jose Ardila, Antabayo, Guadalupe, Gustavo, Jamie, Giselle.
16.
What do you say? H and K. Ask about H and K, no A and B. If you want to participate, say A and B. Okay, I appreciate so much. Who is A and B? Who is A and who is B? Come on, repeat again.
A would be 25 and B would be 16.
Okay, A is 25, A square, no? No A alone, no?
Correct.
And B squared is 16. I agree 100%. Therefore, A is 5 and B is 4. By the way, this ellipse is horizontal or vertical? Horizontal, vertical. The same student, tell me.
Would it be horizontal?
Why? Where is associated the bigger number? Where's the bigger between 25 and 16? 25, no? And 25 is associated with the Y. And Y, the 25, que es the A, que es the major, is that direction, the vertical. Do you see or no?
Yeah, I see it now.
Okay, what about H and K? Who there? Another student, or the same student, it doesn't matter. See, we have only one student to pay attention, it's okay. No idea? Come on, Jose, Gustavo, Rebecca, Benjamin, Jonathan, Daniel. You said no idea? Guy, you see before this in the high school? By the way. Huh? You see this before in high school? Yes or no? Answer me. Whoosh. Where are you? You are here. I haven't. Wow. Say, unbelievable. What happened with the school in the Miami? and the rest. Guy, activate your camera to see your face. I'm not sure. I am not sure. He says I'm not sure. Unbelievable. Unbelievable. Wow. Well, okay. Remember, you need to become professional. And to become too professional, you need to take a lot of subjects in college, in university. And in college, you need to take Calculus 1, Calculus 2, maybe Calculus 3, depending on your major. And you need to use these tools in this advanced mathematics. And also, another subject using this conic section. And you need to be familiar with this. Okay? This is the idea for the pre-calculus. Well. So now, I suppose you see very well the whiteboard, no? Yes or no? Yes. Okay, you said, look. Es obvio que age is 3, que es that number. But you see in the equation, you see minus. Wow, why is 3 positive? Because the equation in general is x minus h squared equal b squared, maybe in this case we discovered the 16 is b, plus y minus k squared equal a squared equal 1. So now, so you see 3 positive, it's because the value of h is positive 3. When you plug it in here, nothing happened. It stays the same, that's negative. However, k is a negative 2, because when you plug it in negative 2 here no, here no, here, plug it in negative here, we have double negative. Negative of the value, negative of the formula, together is positive. Okay, that's one the shortcut to memorize automatically this idea. Easy. It's completely opposite sign. When you see negative number, is the point is positive. So the center of this elixir is located at the point 3, minus 2. Do you see this or no? Yes or no? Yes, it's clear. Okay, now. I need to finish that. So in order to finish, we need the C, que es the focal distance. The focal distance is, the formula is a squared is equal to b squared plus c squared. Therefore, c squared is equal to a squared minus b squared. C squared is 25, b squared is 4, no, it's 16, sorry, 16. Now subtraction of 9, therefore c is 3. Okay, so now my ellipse is vertical. The center is located at the point, so this center here, at the point 3, minus 2. That distance is 5, because it's 8. That distance is also 5 to opposite direction. That distance is 4. That distance is 4. And the focus is from the center. That distance is 3. And that distance is 3. Okay, you can determine any point, addition or subtraction. But no, we are doing using the script that I sent to you when the class is over. Okay, let me try. Example number 3. Okay. Example number 3. Will you see my Desmos? You see or not?
Yes.
Okay. So now remember, let's see. Look, you determine the piece of paper que the center is located at the point 3, minus 2. So h is minus 3. and k is positive 2. No, opposite. I make a mistake. H is positive 3 and k is minus 2. And A is 5 and B is 4. Okay. Okay. Now. Sorry, I forgot the most important. The example 3 elixir is this example. Look, I copy exactly the same formula. Do the graph, bang, something like that, but no information inside. So you can find information inside here. F5, F4, S3, es negative 2, okay. And this is obvio que es vertical ellipse. Boom. Look at that. Center, 3, minus 2. Vertex, 3, 3. And 3, negative 7. Endpoint of the minor axis, 7, minus 2. And negative 1, 2. Focus, foci in plural, 3,1 and 3, negative. And this is logical because that distance F5, look, you go from the center, see this distance F5, it's obvious that you move in vertical, the x component stays the same, is 3, something, 3, something, but the distance between negative 2 and positive 3 is 5. Okay? And the distance between negative 2 and negative 7 is also 5 but in opposite direction. And the distance between this point and this point is 4. So you increase it because you moving horizontal, and the y component stays the same, negative 2, negative 2. However, the x component no is 3 plus 4 is 7, and 3 minus 4 is negative 1. And similar happens with the focal distance, que es 3. O sea, es negative 2 plus 3 is positive 1, and negative 2 minus 3 is negative 1. Say something? Cool? Fantastic? Beautiful. Science fiction. Okay, let's move on to the last example. Good. Gustavo is good. Okay, Gustavo. Okay, entonces now let me move into example 4, que es a little bit more complicated. A little bit more complicated. Look, suppose 3 x squared plus 7 y squared plus 6x minus 28y plus 10 equals 0. Wow, what the hell? Oh, sorry. Sorry, 3, sorry. Thank you. Copy that. 3x squared plus 7y squared plus 6x minus 28y plus 10 equals 0. Of course, this is a totally crazy equation. By the way, this is called a general form. The general form, the format is right hand side 0, and you copy first the quadratic, square in alphabetical order, linear in alphabetical order, and finally the independent term can do not contain variable last, so degree 0. This is general, and this, pero nobody see anything. No. I need immediately to express this in standard form. And standard, remember, is x minus h squared over, I don't know si es a squared or not. Suppose que es a squared. Maybe it's a or it's b, I don't know. Plus y minus k squared over b squared equal 1. I need to modify algebraically this equation to this equation in order to express x separately, y separately, and right hand side 1. Right hand side must be 1. Like that. Okay, let's do it. Let's do it. Let's do it. For doing that, I separate the x part like that. 3x squared plus 6x. Yeah, I separate the y part. I want to put a space here. Well, no. Plus 7 y squared minus 28y. Why no? In this case, I put an equal sign and put minus 10 here. Alright, now I need to complete the square. Complete the square. To complete the square, in this case, it's easy because I see in between this and this, the common factor between 3 and 6 is 3. I factor out 3. I will have x squared plus 2x plus something. It's the magic number that help me to complete this square. Okay, for a moment, I don't touch this. Likewise, you copy plus 7, que is the common factor between 7 and 28 is 7. We have y squared minus 4y plus another box equal minus 10 plus 2 boxes. And remember, inside the boxes, I put the artificial number to help me to complete the square. Do you understand very well this organization? The thing I try to do, the thing I try to do is conversion from general, que is given, to standard. Okay, nice. Okay, cool. As you understand this organization, let's find in now the magic number, the first magic number. Remember the formula, b divided by 2 squared. So in the first trinomial, that one, b is 2. 2 divided by 2 is squared. b is 2. 2 divided by 2 is 1, 1 squared 1. I put 1 here. I know when you put artificially this one, this new trinomial is perfect square, and the factorization is 3 parentheses x plus 1 squared. Yes or no? And the second, well, in the second, no idea, b is 4. I don't care the sign is not important. It's 4. 4 divided by 2 is 2, square is 4 again. 4 divided by 2 is 2, 2 squared is 4, is 4 here. 4 here, does it now the factorization is 7, y minus this sign, and square root 4 is 2. Okay, almost, I finished, because now in the right hand side, you need to write 2 numbers, not necessarily the same, of 1 and 4, because remember, okay, this one is multiplied by 1 extra 3 I factor out at the beginning. The actual is 3. That to keep equilibrium of the equation, this artificial one can I create to complete the square, actually no 1, because 1 times 3 is 3. And this 4 is not 4, it's 28. It's 28 because 4 times 7 is 28. So now, actually, in the right-hand side, we have 30, this and this together is 31, minus 10 is 21. Do you follow me so far? Do you understand this manipulation? Finally, I divided by 21, whole thing. Okay, so we have x plus 1 squared equal 21 divided by 3, 7, plus y minus 2 squared equal 21 divided by 7, 3 equal. Nice, and this is the equation of the hour ellipse expressed in standard form. Guys, this is unbelievable. This is science fiction. Look at that. Look at that. This equation is given at the beginning is 100% equivalent algebraically to this equation. They want to prove in this much. It's the same. Okay? But now it's clear. Everything opened the door to understand this elixir. The center of this elixir is located at the point -1, +2. -1, +2. Look at that number with the opposite sign and that number with the opposite sign. And a squared is 7 and b squared is 3. You take always a the bigger. Therefore, a alone is square root 7, que is irrational, and the answer is 2.645. Approximately, I truncate 3 digits. Now b is square root 3. It's approximately 1.732. One more information we need. Well, we need C, get the focal distance, and that's it. And the focal distance is, let me try again to apply the formula directly. A squared minus b squared is square root 7, que es a squared, minus 3, que es a squared, is 4, and square root 4 is 2. That's the focal distance is 2. By the way, I forgot to analyze. This ellipse is horizontal or vertical? This ellipse look like that or look like that? Vertical, horizontal. What do you think? What do you think? No idea?
Horizontal.
Absolutely. How do you know? What is the reason?
The smaller number is associated to the y.
Exactly. This is the reason. The smaller number 3 is associated with the y, and the bigger number is 7 is associated with x. Entonces es something like that. When I finish, I will take the graph like that, not like that. Okay, cool. Let me try to simulate more clear and decimal because the number look like super complicated to do by hand. So I'm using this like a graphic calculator. You see them way?
Yes.
Yes or no? Yes. Okay, let's move on. Let me erase everything. I move on the graphic, the example 4, no? Yeah. This is example 4. Wow. Look, I copy exactly the same as given. I don't care. I don't do anything. I copy, pagada. Yeah, you see something like that. However, I want to investigate. So I want to investigate. I determined that, for example, A was radical 7. Oh, wow, amazing. Radical 7. To make nice, I using the calculator demos or the keyboard, sorry. It's radical 7. Wow, radical 7. And I have the accuracy information. Now, BBB is radical 3. Radical 3, you. And what about H? And what about K? H is -1. Suppose you make a mistake. No problem. You click here on dot. Automatically change something. On dot. -1. -1 is H. And positive 2 is K. Positive. Super. And you know very well que this belong to the horizontal ellipse, no? Bang! One more time, do cool. Look at that. Center. 1 comma, negative 1,2, sorry. Vertex located in this weird number, but this weird number is obtaining when you adding -1 plus radical 0, -1 minus radical 0, +2 plus radical 3, 2 minus radical 3. And this was nice because the focal distance, remember, was 2. Then you move in horizontal, entonces -1 plus 2 es +1. And -1 minus 2 es -3. Super cool.
Cool.
Eso, bueno. Entonces, let's do something about parabola. I don't know. Let me try to explain the 5 minutes that we have to do at least 1 or 2 problems of the parabola because it's important. Practice this. Okay, I call switch it first to the whiteboard. Check it. Whiteboard. Whiteboard is totally clear. Example number 1 of parabola. Okay. This x squared equal ay. Wow. I remember something. See, when there's x squared and y not squared, it's parabola. Or when there's y squared and x not squared. This is the parabola. But important the classification. This parabola is vertical and this parabola is horizontal. So when you have equation, you identification, wow, it's parabola. You take a look who is square and who is not square. So when this is x squared and y not square, our parabola look like that or like that, depending the p-value, p positive or p negative. I determine now who is p in a few seconds. However, when this is this format, the y is square is not our scenario now. Well, does the parabola look like that? No, sorry. The parabola is, when the p is positive, is to the right. Look, this condition is for this and this. And when the p is negative, is left. Okay, down left, up right. Entonces es obvio, wow. This is the, bueno, this is the ese parabola. And also is vertical, no? Because it's x squared like that, vertical. This is the analysis. Okay, cool. Now we have no translation. So in general, our equation in general look like that. Look, let me show you. X minus h squared equal 4p. Do you understand now what is the reason of the 4p, y minus k? It's a one possibility. Another possibility is y minus k squared equal 4p again, x minus x. It's obvious that the second no apply in this example because the square part is the x, not the y. So basically, if you see x squared equal 4p, y, so this is perfect, matching with this, in which h and k are 0. Now the vertex, que is the technical name of this point is the most important point in the parabola. It's a vertex. Okay, always is located at the point h comma k. In our example, it's located at the point 0, 0. Okay? What about B? When it's obvious, compare this equation, please. And this equation, it's obvious that 4p is equal to 8. Therefore, p is 8 divided by 4 get 2. P is positive. If P is positive, and this is vertical, our parabola open over. So two important conclusions. P positive over, and this famous important point is 0, 0. So far it's okay?
Yeah. Yeah.
Aha. Let's finish at least one problem of the book. Now, one more thing I need to know. Well, I need to know if you have in your hand P, this is X, this is Y, this is the vertex 0, 0, P is 2, this is the focus, look at 1, 2, here is the focus, 0, 2. Aha, I am ready to write the parabola. No. Why no? Because you need to find the focal diameter that give me information how wider or narrow is our parabola. And this distance is 2p to b. 2p to b, in our specific example, 2p is 4, no? 2p is equal to 4. So you know, 1, 2, 3, 4. This is 2p. By the way, this point is located, is the point 4, 2. And this point is 1, 2, 3, 4. This point is a point negative 4, 2. Okay, so I have approximation, my parabola look like that. Let me try to do my best, but my best I am doing in this move. One more information I need. I need the axial symmetry. Axial symmetry is exactly coincident with the y-axis. Axis of symmetry. Okay, by the way, the equation is x equals 0 or y-axis is the equivalent, same idea. And directrix is also a line, but this line is the same distance get 2. So that distance, get the focal distance, is the same distance in opposite direction. And this is a horizontal line. This line is called directrix. And the equation for the directrix, a horizontal line, is y equal -2. This is the equation for the directrix. This is the equation for the axial symmetry. That's it. Okay, guys. So now, please, one more time, I recall. Today is the day for send me by email the test online on paper, sorry, and submit and artist the test online. Clear? Clear.
Yeah.
Oh, super. We are the best. Come on. In a few minutes, I send the video. I send the link to connecting with this important script of Desmos. Okay? For the coding section. Bye-bye. See you.
Thank you, Professor. Bye.